Flim Flam.
All right, kids, hey, check it. You're going to go ahead and get a look at making linear equations off a coordinate plane. Take a look at page 108 and 109 in your books, and let's get started. All right? Boom.
To write an equation from a coordinate plane, we need to remember our linear equation y equals mx plus b, knowing that the mx, that would be our slope, and our b would be our y-intercept. We can use the coordinate plane and figure out how to write an equation. So let's take a look up here at this coordinate plane, and you can see that this line has been marked out with rise over run, and your rise over run is your y over x, okay? And you can see what your x value would be, that is 2, and your y would be -3, denoting that this is a negative slope. And you can see that they've written it out over here that the slope is a -3/2, which is -3/2 here. You can write your equation, since you know that your slope is 3/2, and you can see where this line crosses the y-intercept, which is right here, and that is a +5, and that is how you write your equation. Here's our second example, and take note of the x value and the y value. These coordinates have been placed here. You see these two dots, and they've been connected by a line, and our x value is 3 and our y value is 5, and you can see that as rise over run, that it is y over x, and you can plug that into the y equals mx plus b down here and make your equation. So they have written out the slope as 5/3x plus a -3. The -3 comes from right here, and that is where this line crosses the y-axis, the y-intercept. And you can see that they've written it out as y equals 5/3x plus a -3, or you can write it out as y equals 5/3x minus 3 is the same thing. Here's our first example in the book, and we're going to take a look at this coordinate plane and figure out how we can write an equation for this line here. Denote that you need to figure out what the slope is, remembering that that is the difference in y over the difference in x. So we're going to go ahead and see this information right here, noting that this is our y value and this is our x value, and we can write what the slope is. And we will place that right here. So y is 2 and x is 1. This is actually just 2. Okay, 2x, and we can start to write our equation out. So y equals 2x, and we will say plus, and b is where this line crosses the y-intercept. And you can count up from the origin, and that is 1, 2 on the y-intercept, the y-axis I should say. So that means b will be 2. And we can write that down and finish our equation, and that will be y equals 2x plus 2. Please note that all I did to get this equation was plug in the numbers from this coordinate plane into this equation right here, our slope-intercept equation. Here's our second problem from On Your Own, and we want to find the slope of this line, and we will take a look at this information here on the coordinate plane, denoting that this is our x value and this is our y value. You can see that x is 3 and y is negative 4. So we can go ahead and place that, our y as in negative 4, and our x value is 3. So our slope will be negative 4/3. And where this line crosses the y-intercept is at negative 1. Notice that this is a negative slope, which pertains to the negative symbol here in front of our fraction. So the y-intercept is negative 1. Let me write that down. And we can rewrite this as y equals negative 4/3 x. And you could say it plus a minus 1, or just write it out as minus 1. And this would be your answer for the equation of this line right here.
Taking a look at this standardized test practice sample here, take a look at the coordinates that are placed here. They're asking you which equation is shown in the graph over here. So if you take a look at this point, negative 3, negative 4, and 0, negative 4, let's look at that there's no slope here. This is a horizontal line. Which one is it? Well, where does this line cross the y-axis? It actually crosses the y-axis at, if you count down, you have negative 1, negative 2, negative 3, negative 4 right here. You can see that our answer should be A. Y equals negative 4. Pretty simple. Let's take a look at this real-life application. Following here, this is in your book, the graph shows the distance remaining to complete a tunnel. And you can see some information on the side. It's always important to pay attention to what the pictures and the words below a picture say. Engineers using a tunnel boring machines like the one shown above dig an extension of the Metro Gold Line in Los Angeles. The new tunnels are 1.7 miles long and 21 feet wide. Pretty cool machine. Finding the slope, you can see in this graph over here, denoting the information of the labels. This is important for when you make your own graphs, that you do make your labels clear with your intervals. And you can see this goes 500 feet every jump, 500 to 1,000, all the way up to 4,000. This is our y-axis. Our x-axis is time in months. You can see that they have plotted 2 points, 0 and 3,500, and 4 and 1,500. You can see that our rise over run is going to be negative 2,000 over 4. And that is our slope, because our line crosses the y-axis at 3,500. The y-intercept is 3,500 right here. So we have both of our slope and our y-axis. Intercept. And denote that you have 1,500 and 3,500. The difference between that is 500, and that gives us our slope of negative 500 x plus 3,500 for our total equation on this. Part B, the tunnel is complete when the distance remaining is 0 feet. So find the value of x when y equals 0. And if you plug that in, you can go ahead and solve for x, and you're going to subtract 3,500 from either side, and then solve for x, and x will equal 7. So it takes 7 months to complete this tunnel. Problem 3 wants you to write an equation of a line that passes through 2 coordinate points, 0, 5 and 4, 5. So the first point that I put down here is 0, 5. There's 0 on the x-axis, okay, and I forgot to denote that these are
the X and Y coordinates here, and we have X over here, and this is our Y axis up here, and you can see that there is no movement on the X axis but movement on the Y, so that's why we have 0, 5 placed here, and our other point plotted is 4, 5, so we go up 4 on the X-axis and then up 5 on the Y-axis. So what is our line? Well, we need to figure out what the equation is for this line here. And I will go ahead and put this on these two dots. And you can see that there is no slope. It is a horizontal line. So we just need to figure out, well, where does this cross the y-axis? It crosses at a positive 5. So our equation for this line will be y equals 5. That's it. Here's your assignment, guys, numbers 1, 2, and then 5 through 17. Denote those graphs on 5 through 17. Use this information, y equals mx plus b. Find the slope and find the y-intercept. That's where the line crosses the y-axis, and you'll be able to go ahead and fill out each of those to write an equation of the line on the graph. Good luck.